Hello guys, MJ here with MBJ Knowledge. Today you are going to learn how to handle vector geometry. Okay, don't click out. There are some concepts that I'm going to explain as we go on expanding our lesson today. So you don't want to miss out. Don't skip any step because once you skip, you're not going to learn certain concepts that I'm going to explain. Okay, so we have a question today. In fact, we have two. Okay, so vectors, from the word vectors, this simply means a quantity that has got both magnitude and direction. So on a vector, you are going to see magnitude, meaning size. At the same time, you're going to see direction. Then you're going to say that is a vector. So the way we handle vector geometry, it's different from handling just component vectors. Okay, now look at the way we're going to solve this question. The diagram below shows a trapezium in which OA is equal to vector OA is equal to A, vector OC is equal to C, then vector CB is parallel to OA, CB is twice vector OA. The points D and E are midpoints of AB and CB respectively. This is the diagram. One most important thing when you're dealing with coordinate geometry, vector geometry, is that you are supposed to read out the statements given. Because if you miss out from the statements, then certain questions will not be possible. This is the part one of vectors. We are going to handle questions that do not involve ratios, meaning you don't want to miss the part two where we have ratios, so that you have a clear picture on how to handle vectors. The first question is saying express in terms of A and or B the following vectors. Okay, meaning they can either be A alone, or you can have both A and B on your answers. The first question is saying find vector AC. Now let me give you this trick. Okay, let's say for instance we want to find vector AB. Okay, maybe let me put something which is not here. Let's say we want to find vector DH. Okay, the vector we're trying to find is vector DH. Okay, now when you're dealing with vector geometry, you are finding routes or directions, okay, for you to be able to find the magnitude of that given vector. So in this case, for us to be able to find vector DH that I'm showing here, this D is our starting point, meaning I cannot start from anywhere else but where? At D. So D is the starting point. Whether I like it or not, if I'm using two routes, okay, or two directions, it means it will have 4 slots plus, okay. So the first slot here, it will carry the first letter of my vector I'm trying to find. So I'm finding DH, meaning the first letter should be D. The last letter here should be H. Are you getting some sense there? Then, so if I'm going from D maybe to A, okay, the last letter here on my first vector or my first direction will be my starting point here on the next vector. So meaning the route that can give us DH is vector DA plus vector AH. So look at this. The first letter here and the last letter, they are giving us the vector we are trying to solve. That is a secret you need to remember. Okay, when you're picking directions, make sure your first letter is your starting point. Your last letter of your vector should be the last letter, your ending point. So it doesn't matter how many routes you are going to use. Let us start our question. So here we're trying to find vector CA. That is C to A. So I've said the first letter becomes our starting point. So C is our starting point. Now, if we go from C to B, then B to A, we are going to get stuck. Why? Of course we have CB, but we do not have BA. That vector we don't have. meaning we cannot go in this direction. The best direction we can go is from C to O. Okay, so let us write that one down. So CO, we are going from C to O. C is my starting point. My ending point should be A. Then O to A. Have you seen what is happening here? The first letter and the last letter, they are giving us the vector we are trying to find. Then look at the letters that are inside. They are the same. Meaning, if I'm ending at O, on the next vector or the next route, I'm going to start from O. I hope that is making sense. Okay? Then let us now substitute our values. Vector CO, we are going against the arrow, meaning the C, we introduce a negative to show that we are going against the arrow. Always remember, when you're going against the arrow, you put a negative. So CO will be negative C. Then OA, we are going in the direction of the arrow, so positive A. Then make sure you interchange here. The positive needs to overpower the negative. So the A will be at the beginning, then the C at the end. Okay, so the last or the final answer for vector CA is A minus C. Okay, then Roman numeral 2, find vector AB. AB, vector AB. Are you saying that? Okay, so for us to find vector AB, the first step, we need to find the roots. Okay, so the roots, for me to find vector AB, remember A is the starting point. Okay, but we don't go in the same direction as the root I'm finding. So I can't go from A to B. No, we can only go from A to C. Okay, since we have already found the CA, so we can go in this direction, there is no problem. Or you can go from A to O, then from O to C, then from C to B. Then you can find. Okay, for me, I'm going to use this route because I've already found the AC. CA we found. Okay, CA we found, so that route we can use it. Okay, and that is how the route that we're going to use. Okay, so let us start. So we have AC, so I'm going from A to C, then I'll start from C going to B. Okay, now from here, AC, okay, you might ask yourself, so where do we get the AC? Remember, on the first step here, we found CA. So AC is going in the opposite direction as CA, because CA is starting from C going to A. That is the direction. But now AC, you're going against this arrow, meaning you have to introduce a negative to CA. Okay, so negative CA will give us AC. So when we multiply this negative to A, the A will be negative. You multiply this negative to negative C, the C will become positive. So AC will be negative A plus C, positive C. Are you getting it there? Please don't click out. We are still solving some nice questions, okay? Then let us substitute. So this is our AC. Then CB. When we go back to our statement, they're saying CB is twice OA. So twice means 2 times OA. OA is just A. Okay? So twice, we multiply a 2 with the magnitude of OA. So it will just be 2A. Putting it back here, it becomes this. Then we put the like terms together. So the positive 2A will just be pushed here where the like term is. Please do not change the sign. They are not crossing an equal sign here, so maintain their sign. So the 2A will come here, then the positive C will go there. Then here, negative A plus 2A, okay, the answer there is A plus C. This is the final answer for AB. Okay, we proceed to question 3. Find vector EB. EB. So EB is just here. Okay, now going back to the statement, they are saying E is the midpoint. Okay, so E is the midpoint of CB, meaning it is in the middle. It is cutting this line CB halfway. Okay, so if CB is 2A, okay, what is half of CB? What is half of 2A? So EB will just be half of CB. Okay, taking half of 2A will give us the 2 into 2 will give us 1. What is 1 times A? So EB will just be A. So EB there is half of CB. Okay, we proceed to question 4. Question 4 is saying find OD. Okay, so from O going up to D right there. Okay, so O is our starting point. Okay, so in this case, since we have found AB, it is easier now. We can use this direction from O to A, then from A to D. Okay, now get it right here. Okay, this is the direction O to A, then A to D. All right, from here, O to A we're going in the same direction as the arrow, so the OA will be just the A. Good. What about AD? Okay, AD, look at the statement. D is also a midpoint, meaning it is cutting AB into 2 equal halves. So AD is half of AB. Okay, let us find the AD first of all. So half of AB. We found AB. Okay, on the previous question we found AB. So the way vectors works, you make a mistake on the previous question, it means most of the questions where you're going, you make mistakes. Okay, so find AB. AB we found already, so half of that will multiply what is 1 over 2 times A, which is, this is the answer here. When we multiply half with all the terms inside the brackets, let us substitute it. Then from here we have A and the 1 over 2A as like terms. So we can introduce a 1 on A, find the common denominator, which is a 2. Then 1 into 2, that is 2. 2 times A, we have 2A. 2 into 2, that is 1. 1 times the positive 1A will get A. Okay, then here we can add. Okay, let us bring the 1 over 2 C. Then 2A plus A, that is a 3A over 2, then plus 1 over 2C. This is the final answer for OD. All right, we proceed to BO. So we are trying to find now vector BO from B to O. Very easy, right? I know even people are now finding. So BO, the starting point is B. So I'm going from B to C, then from C to O. Okay, so B to C, then C to O. BC is going in the opposite direction as your arrow, meaning you introduce a negative. All right, so we introduce a negative on our CB. CB is just 2A, so negative of that. Okay, so negative 2A. Then CO, again, you're also going in the opposite direction as the arrow, so the C will have a negative. This is the final answer. Okay, that's our final answer right over there. Okay, let us go to the next question. Okay, let us practice on this question, which is a bit complex, all right, than the one that we had. Okay, they're saying in a triangle OPR below, the line OX produced meets PR at Y. PQ and OY meet at X, such that XQ is equal to 1 over 3 of PQ. Okay, then OP, vector OP is equal to P, vector OQ is equal to Q, and OQ is equal to QR. Okay, it's indicated here. All right, so express each of the following as simply as possible in terms of P and OQ. Vector PQ. Okay, since we've learned that writing a vector, we are supposed to start with the starting point, which is the first letter given on our vector we're trying to solve. So finding vector PQ, the starting point is P. Okay? So we are going to go from P to O. We are not going to go from P to R because we do not know the quantity here on P to R. So we'll go from P to O, okay? Then from O to Q. We are stopping at Q because Q is our last letter here. So as you can see there, okay? What is the value for PO? PO, you're going against the arrow. So on the P, you're going to introduce a negative. All right? I hope that is okay. So introduce a negative, so negative P. Then OQ, you are going in the same direction as the arrow. So no need for putting a negative. So that's a positive. Then interchange. Okay, the negative. Then we have Q minus P as our PQ. All right? Let us go for B. Find vector OX. So OX. Okay. So we can go from O to P, then P to X. Okay? Or OQ, then Q to X. They are just okay. But now, if we go from O to P, then P to X, we are going to be stuck on this ratio here for PX because we have not been given the ratio in the statement. But the statement that has been given there is for vector XQ. They're saying XQ is 1 over 3, 1/3 of PQ. So meaning the best direction for OX is OQ, then QX. Okay, so OQ, then QX. Because OQ is just Q. We are going in the same direction as the arrow. Then then QX, okay? The vector that we just found, okay? The vector that we just found, it is going from P to Q, okay? The arrow is like this, the PQ, going from P to Q. But now we are going against that arrow, QX. So it should be, first of all, let us find the XQ. All right, XQ first of all. So XQ is 1/3 of PQ, meaning you multiply the PQ with 1 over 3. So multiplying that, we'll just have 1 over 3Q minus 1 over 3P. Okay? Then now it will be the opposite of this, meaning you multiply that one with a negative. So multiply a negative on XQ, then it means what you are going to get now is QX. So multiplying with a negative, this will be a positive, the negative 1 over 3P, and then the positive 1 over 3Q will be a negative. So this is our QX after multiplying a negative to XQ. All right, let us substitute. So now this Q and this, they are like terms. Introduce a 1 on Q, common denominator, which is a 3. 1 into 3, that's 3. 3 times Q, we have 3Q. Then 3 into 3, that is a 1. 1 times negative 1Q, it will be negative Q. Okay, bring that one just as it is. Then here we subtract, so we have 2Q over 3 plus 1 over 3P. This is the value for OX as our vector. Let us go for the last one. Okay, so the last one is saying, given that OY is equal to HOX, show that PY, okay, show that vector PY is equal to what is given here. Okay, when a question comes asking us to show, it's the simplest because it's like someone has already prepared fried chicken, and then they ask you to say, can you show that this chicken is fried? How do you fry chicken? You start following. You even know, can you show the way this chicken looks, how you can get this result? Okay, definitely when you just look at it, you see this is a fried chicken. So when you are given that piece, you are just going to do exactly what they've done. If they've added some spices, just by looking, you do the same. And that is what we are going to do. So before we come to the showing, first of all, there's this part which is very important. So whether we like it or not, we are supposed to handle this first part. Let us first of all find vector OY. So vector OY, we are not going to use directions there. We've been given to say you multiply with this, okay, H, multiply it with vector OX, then that will give you OY. So let us multiply H with vector OX. We found OX, okay? So OX is 2Q over 3 plus 1 over 3P. That is our OX. Now multiply it with H now. So when we multiply with H, the H will go in between here, in between 2 and your vector, okay? So H times that will have 2HQ over 3 plus 1HP, okay? 1 over 3 HP. This is our OY, okay? After finding OY, now we can go ahead and begin to show. So PY will be equal to, now this one that we are trying to show, we are supposed to pick directions now. But put this one into consideration. Whether we like it or not, we are supposed to use this as one of the directions, the OY. Look at what we are showing. There's an H. And when you go back to your diagram there is nowhere where we've been given an H. Meaning an H can only come if you use the direction of what? Vector OY. So whatever directions we are picking, OY should be there. Okay? So P is our starting point. Okay? So we can go in which direction? We are finding PY. So from P, okay? From P, we are going to go from P to O. Okay? From P to where? To O. Okay? That is our first direction. Then I cannot go from O to R because I want this OY to be there. Then it means we'll go from O to Y. Okay, so PO plus OY. Those are the vectors we're going to use. Vector PO is what? Opposite. We're going in the opposite direction to the arrow. So opposite of OP is negative P. Okay? Then OY, we've already found OY here. So we introduce it. Now, when you reach at this stage, because you are showing, don't factorize it the way you feel like factorizing. No. Check what is here. Okay? There is this quantity that has not been touched. The positive 2 over what? 3HQ. This has not been touched. So from here, this is the 2 over 3HQ. So this, we also need not to touch it. Okay? If we are to follow what is happening there. Okay? So let us start. So this part here, okay, this part here is not going to be touched. This and this, it means, have you seen what is happening here? The 1 over 3H minus 1. And then there's the P outside. So meaning it is these two. So there's a positive at the beginning. So 1 over 3HP, it's the one which is at the beginning. Then here where there's minus 1, it means it's this, the negative P. Okay? The 2HQ over 3 has not been touched, so it goes at the end. From here, we find what is common according to what they've done. So, have you seen what they've done? They've taken what is common outside. So, they didn't write what is common. So, when you take out the P here, you remain with 1 over 3H. This is the 1 over 3H minus P dividing into P, that is 1. So, negative 1 here. The P, they didn't put a P here. The P, they've put it on the other side, on the right-hand side of that bracket. And that's where we're going to put it as well. Okay? So the P is there. At the same time, the other part just comes as it is. So look at this. On this part here on top, it is 2HQ. But we've dropped the HQ to the vulgar form on this part here. because that's how they've written it. So we're just showing exactly what they've done. That's how we are simplifying it. Okay? So when you reach at this stage, you even write down to say, hence shown. So thank you very much, guys, for watching up to the end. Make sure you like, comment, and share the video. Don't forget that this is just a part 1. There's a part 2 which is coming. Okay? So watch other videos. I'm going to link it in the description, or I'm going to put it on the, when you see something popping up, just click there so that you watch other videos. See you in the next video.